Okay, so in this video we're going to have a look at 6 of the hardest styles of functions questions. So I'm going to assume a lot of knowledge in terms of your actual functions in this video, so do check out the video on composite and inverse functions, which I have in the description below as the start of this series. Okay, but we're going to have a look at 6 of these questions. They're all relatively tough, they're in no particular order, but they all have sort of different wordings and different processes and different sort of ways that we might approach them. So we're going to have a look at these 6 questions, so grab a piece of paper, grab a pen, make some notes, and we're going to kickstart with this question. Now, as with all these types of videos that I'm doing, with these types of questions here, we're not going to be stopping at any point for you to have a go. So if you do just want to have a go at the question before I go over them, obviously you can pause the video, have a go at the question, and then have a look through the solution and see how you've fared up in each particular question. But this one says the function f is such that f of x equals 4x minus 1, and the function g is such that g of x equals kx squared, where k is a constant. Given that fg2 equals 12, work out the value of k. So k is a particular number, and we're going to find out what that number actually is. So if we go about having a look at this information to start with, it says here that fg2 equals 12. Well, let's have a look at actually working out fg2 and see if we can actually do that. Now, fg2 means it wants us to sub g into f and then put the number 2 in. So if we go about doing that, let's put a bracket around g and put it into f. So if we do that, let's have a look. We get 4 lots of kx squared. Just write that a little bit clearer. 4 lots of kx squared. There we go, in brackets, and then take away 1. And it says that when we put 2 into that, it's going to equal 12. Well, there's our function fgx. Let's just write that. There we go. Okay, so putting 2 in place of x now, let's see what we get here. We get 4 lots of, and we've got k lots of 2 squared. Now 2 squared is 4, so rather than writing k4, I'm going to write 4k. So 4 lots of 4k, and then take away 1. And it says that that equals 12. Again, I'm just getting the information just from this little bit here. Okay, so we've subbed in 2, and that is equal to 12. So k lots of x squared turns into 4k, and now we've set it equal to 12, and we can go about thinking about our next step here. Now we've got 4 lots of 4k, so we can expand this little bracket here, and that gives us 16k. So we have 16k, take away 1, and that equals 12. And that's just a nice little easy equation for us to solve now. We can add 1 to both sides. So if we add 1 to both sides here, we get 16k. That is not a 6, there we go. 16k equals 13. And then we can solve that nice and easy, dividing by 13, and we get k is equal to 13 over 16. There we go, and that doesn't simplify, so we'd leave our answer just like that. K is equal to 13 over 16. So a little bit of a strange question, obviously different to some of the other functions questions that I've looked at in previous videos, but actually I think this is probably one of the easier ones out of the bunch there, because actually all we had to do was sub a function into another, put the number in and solve it as a little equation. But there we go, there's our first question. We're going to start having a look at our next one, and here it is. Okay, so this question says, for all values of x, f of x equals 2x minus 3, and g of x equals x squared plus 2. And then it says solve when fgx equals gfx. So we need to find the expressions for fgx and for gfx. So let's start with fgx. So for fgx, we're going to put g into f. So let's write this down, fgx. And for this one here, let's have a look. We're going to put g into f, so let's put a bracket around g. And we'll put it into f. So we get 2 lots of x squared plus 2, and then we're going to take away 3. So there's an expression for that, which we'll tidy up in a sec. And then we've also got gfx. There we go. So for this one here, we're going to put f into g, and let's just put a bracket around f, and again put it in place of the x in g. So gfx is going to equal, and that is in brackets, the 2x minus 3. X is being squared, so that's squared, and then plus 2. There we go. So we've got our expressions. Let's just tidy these up and see what we get when we expand all these brackets. So for the first one there, we've got 2 lots of x squared, so that's 2x squared. 2 lots of the 2, so that's 4. And then we're going to take away 3. And 4 take away 3 is 1, so we can tidy all that up, and we get 2x squared plus 1. There we are, and there's our first simplified expression there. Let's have a look at our next one. So this one here, we've got 2x minus 3 in brackets squared, so that's a double bracket. So we've got 2x minus 3 and another 2x minus 3. And then at the end there, we're going to add 2 to whatever we get at the end. So let's tidy that up then. Let's expand this bracket. So 2x times 2x gives us 4x squared. We've got 2x times the negative 3, which is negative 6x. Then we've got another negative 6x, and then negative 3 times negative 3 gives us plus 9. And then we've also got the plus 2 at the end there. And if we simplify all of that and tidy that all up, let's see what we get. We get 4x squared minus 6x makes minus 12x. And then we have the plus 9 plus 2, which is plus 11. There we go, so there's our two expressions. So we've got f gx, which is 2x squared plus 1, and we've got gfx, which is our 4x squared minus 12x plus 11. Now it says up in the question here, if we get rid of this, it says solve when they equal each other. So we've got our two expressions. All we're going to do is put an equal sign in between them now and have a look at how we go about solving that. So let's get rid of some of all this stuff. Let's just get rid of all of that. We'll leave our little expressions there, and we're just going to say that they equal each other. So we've got our first one. It doesn't matter what order we put these in, but if we just move this one up to here, there we go, and we're just going to say that they equal each other. And actually we just need to go about solving this now. So that is a quadratic there, and when we have a quadratic, and we're solving a quadratic, we need to make it equal 0. So I'm going to take away the smallest value of x squared from both sides, which is the 2x squared. So we'll take away 2x squared from both sides. There we go, and that leaves us with 2x squared over here, minus 12x, plus 11, and that is going to equal that 1 over there. Now we just need to obviously make it equal 0 again, so we need to get rid of this 1. I'm going to take away 1 from both sides, and that leaves us with 2x squared, minus 12x, plus 10. There we go, and that is now equal to 0. So we're going into the realms of solving quadratics here, so that is obviously a separate topic on its own to functions. So we're actually looking at solving a quadratic, just so you know the names of some of these pieces, just in case you are a little bit unsure about how we're going about this. So there we go, that is that. We now need to actually solve it, so let's move this out of the way. There we go. So our little quadratic there that we're going to solve, there is a way of simplifying this first. If you have a look, all the coefficients of x here are even numbers, and we've got a 10 at the end. So we can go about dividing all of these numbers by 2. So if we divide both sides by 2 here, that's going to simplify this quadratic for us. So let's have a look at what we actually get for that. So 2x squared divided by 2 is x squared. Dividing 12 by 2 gives us the 6x, and we've got the 5 at the end, and that is all equal to 0. And now we can go about actually looking at factorising this. So if we have a look, we've got a 5 at the end, so we've got 1 and 5 for our factors, and that means in our bracket we're only going to have 1 and 5. Now we're trying to make negative 6 in the middle there, so the two numbers that times to make 5 are going to be minus 1 and minus 5. That gives us negative 6 in the middle, and that obviously gives us our two solutions there. We get x is equal to positive 1 and x is equal to positive 5. And there we go, there's our two solutions here. So we had quite a lot going on in that question. We had forming our expressions for f, gx and gfx, and then actually using that to form and solve a quadratic, and actually factorising there and getting our two solutions. So let's have a look at our next question. Okay, so this question says the function f is such that f of x equals, and then we have these two algebraic fractions, 1 over x plus 2, add 1 over x minus 3. It says given that f of x equals 4, find the possible values of x, and give your answer in the form p plus or minus root q over r, where p, q and r are positive integers. So this was a non-calculated question here, and we're going to have a look at how to actually go about solving this. Now it says that obviously the function f of x equals this thing over there, and it says that given f of x equals 4, find the possible values of x. Now if we write that, we've got 1 over x plus 2, and that's being added to 1 over x minus 3, and it says that that equals 4. Now if we actually go about looking at this now, we've got an equation, okay, and we've got an equation involving algebraic fractions. So in order to solve this equation, we first need to combine these algebraic fractions, and in order to do that we need a common denominator. So to get a common denominator here, we're going to have to times the left fraction by the x minus 3 on the bottom of the right. So we're going to times the top and bottom by the x minus 3 there, and we're going to times the bottom as well. Here we go, so let's write that in, x minus 3. And we're going to times the right one, top and bottom, by the x plus 2 on the opposite fraction there. So we're going to times by x plus 2. and times again here by x plus 2. Right, so let's go back actually looking at this. So on the top there, if we do the one on the left to start with, it's only 1 on the top, so that's quite nice. We have x minus 3 all over, and we've got a double bracket on the bottom there, which is x plus 2, x minus 3. There we go, so we can just leave that in a double bracket for the moment. That's x minus 3 and x plus 2. There we go, and we're going to add to that, and the right fraction there, it's only a 1 on the top again, so we've got 1 times x plus 2, so x plus 2 on the top, and on the bottom we've got our double bracket there, x minus 3 and x plus 2. And again, that's all equal to 4. Right, okay, so we can go about actually combining these now. So we can add together those numerators. We've got x, add the other x over there, so that gives us 2x on the top. And we've got negative 3, and we're going to add the 2. So negative 3 add 2 is negative 1. So we have 2x minus 1 on the top. On the bottom, we have this double bracket. We can actually go about expanding that now. So let's expand that double bracket. I'm going to do that from the bottom. So we have x times x, which is x squared. We have x times the positive 2, so plus 2x. We've also got the minus 3x. I'm just going to sort that out down here just to avoid it. Lots of steps here. So we've got plus 2x and minus the 3x. And plus 2x minus 3x leaves us with negative 1x, so minus x. And then we also have negative 3 times the 2, which is negative 6. There we go, and that is all equal to 4. There we go, so that equals 4. So now we've got an equation that we can go about rearranging. We obviously don't want fractions in our equation, so let's multiply that denominator up to the 4. So I'm just going to times both sides by x squared minus x minus 6. If I put that in a bracket, and that's just going to multiply up here next to the 4. So we've got 2x minus 1 on the left, minus 1, and that is equal to 4 lots of that denominator there, x squared minus x minus 6. There we go, so let's multiply that bracket out now. So we've got 2x minus 1, and that equals, we've got 4 lots of x squared, so 4x squared. We've got 4 lots of negative x, so negative 4x, and 4 lots of negative 6, so negative 24. There we go, so we have a quadratic on the right there, so we've got a quadratic equation similar to one of our previous questions, and again we need to make it equal 0. So rather than moving that 4x squared over to the left hand side, I'm just going to move everything onto the right hand side to make it equal 0. So let's minus the 2x from both sides, and I'm also going to add 1 to both sides. I'm going to do that in one step. So if we do all of that, let's have a look. So I'm going to get rid of some of my previous working out now, so make a bit of space. So let's get rid of all of this. There we go. And we'll bring this up to the other side. Okay, so we have 0 equals, we're taking away the 2x and we're adding 1, so nothing's happening to that 4x squared, so we've still got 4x squared. We are going to minus 2x from this negative 4x, that gives us negative 6x. And we're adding 1 to that minus 24, so add 1 to minus 24 is minus 23. There we go. So we've got our quadratic equation now, it equals 0, and it says give it in the form p plus and minus root q over r, where p, q and r are positive integers. So obviously what we need to do is obviously think about our solution here, and that gives us a big hint that it doesn't factorise. So we're going to put it into the quadratic formula. So if I get rid of all of this, make a bit more space, and we're going to write down the quadratic formula. So the quadratic formula is minus b plus and minus the square root of b squared minus 4ac all over 2a. So we've got our value of a, which is 4, we've got our value of b, which is negative 6, and we've got our value of c, which is the negative 23 at the end there. So let's just put all these pieces into our quadratic formula and see what we get. So minus b at the start, well b is negative 6, that becomes positive 6, plus and minus the square root of b squared, so negative 6 squared is 36, minus 4ac, so 4 times negative 23. Let's work that out to the side, this 4ac part. So 4 times 4 times negative 23. There we go. So 4 times 4 is 16. So we have 16 times negative 23, and that comes out as negative 368. There we go, so that's minus 368. So we've got 36, take away negative 368, and that's all over 2a, and 2 times a, 2 times 4 is 8. Now one thing we can actually just sort right in the middle there, we've got taking away negative 368, so we've got those two minuses, so let's turn that into a plus, we'll get rid of that. There we go, so we have 36 plus 368 underneath our square root there. So if we actually just add those together, 36 plus 368 is 404. So we have 6 plus and minus the square root of 404. There we go, all over 8. Right, and there's our final answer. There we go, so we've got that in the form that it's asking for, p plus and minus root q over r, so p is 6, q is 404, and r equals 8. And that's our final answer there, in that form that it's asking for. Obviously just thinking about using the quadratic formula there, and actually just plugging in all the pieces and simplifying it down without actually typing it in. Obviously if it wanted us to work out the values of x at this point, we could just type that into the calculator and get our two values, but it asks for us just to leave it in that form, which basically just means using the quadratic formula without actually pressing the equals button and doing our plus and our minus version. But there we go, that is that question, and we're going to move on to our next one. Here it is. Okay, so this question here is split into two parts, so we're going to focus on this first part to start with, and it says the function f is given by, and we've got f of x is 2x cubed minus 4, and it wants us to show that the inverse function of f when we sub in 50 is equal to 3. So what we need to do is find the inverse function of f to start with. So when I do this, I do swap it for y equals. So we've got y equals 2x cubed minus 4. So if we go about rearranging that, I'm going to jump a few steps here, but we've got y, we're going to add 4 to both sides, so add 4. That would leave us with 2x cubed on the other side. Then we need to divide by 2. There we go, and that would leave us with x cubed, and then we need to cube root that. So there we go, I've jumped quite a lot of steps there doing that in one go, but that is our inverse function, and that would be equal to x. So that's our inverse function there. So if we write that, we've got our inverse function of f minus 1 of x, swap round our x and y's again, and we get the cube root of x plus 4 divided by 2. And then we need to go about subbing 50 in. So if we sub 50 in, let's see what we get. We end up with the cube root of 50 plus 4, all divided by 2. And let's see what that is. So 50 plus 4 is 54, divided by 2, leaves us with 27. So we have the cube root of 27, and the cube root of 27 equals 3. There we go. So that's shown that that is equal to 3 there. And that is the first part of that question. So obviously there was a nice little starting question there, not particularly the nicest, because you've still got to do the inverse function, subbing in a number and showing that it equals something. But again, obviously just thinking about those steps there where I've done the inverse, if I slow that down ever so slightly up here, we've got y plus 4 to start with is equal to 2x cubed. There we go. Then I divided by 2, so it's y plus 4 over 2. Which is equal to x cubed, and then I cube rooted both sides. Okay, so that's how I got to obviously this function over here that we actually ended up subbing into, and there's our little part A question for this one. Then for the next part of this question, it says the functions g and h are given by g of x equals x plus 2 and h of x equals x squared. It says find the value of x for which hgx is equal to 3x squared plus x minus 1. Well, to start with for this question, we need to find what hgx is, and that means subbing g into h there. So if we sub g into h, we need to put a bracket round g and sub it into h. So our expression for hgx is going to be equal to, and let's see, we put that in brackets, so we've got x plus 2, and that is x squared, so that's x plus 2 squared. And if we expand that, let's see what we get. That's obviously a double bracket, so that is equal to x plus 2 in brackets. There we go, and if we expand that, that's going to give us our quadratic here. So we've got x times x, which is x squared. Let's just do this in steps. So we have x squared. There we go. X times 2 is 2x. Underneath we've got another 2x. And then 2 times 2 is 4. There we go, so our final expression there, once we simplify these middle two, we get x squared plus 4x plus 4 as our final expression for hgx. Now it says in the question, find the values for when that is equal to 3x squared plus x minus 1. So let's set that equal to that. So we've got that is equal to 3x squared plus x minus 1. And again, we have a quadratic. So when we've got a quadratic and we're looking to solve it to find the value of x, we need to set it equal to 0. So we need to start moving everything around and get an equal on one of the sides. So I'm going to get rid of the smallest value of x squared to start with. So I'm going to minus x squared on the left, so we'll have 0 on the left. So we've got minus x squared, let's do that. So over here, that's going to leave us with 2x squared. Then I'm going to get rid of that 4x there, so let's do that in steps. So we're going to minus 4x from both sides. There we go, so positive x, take away 4x, leaves us with negative 3x. And then as well, I need to also, let's have a look, let's see if I've got a different colour here. We need to minus the 4 from both sides if we want 0 over here. So minus 4 from both sides. So negative 1, take away 4 is negative 5. And now that is leaving us with 0 on the left there. There we go, I've done that in one step rather than doing it in 3 steps, just saving a bit of working out space. Okay, so just moved everything on the left over to the right there. Now let's have a look, what can we going to do from here? So let's get rid of some of this working out. There we go. And let's just get rid of all of this. This is our quadratic that we're left with here. Okay, so now we've got that is equal to 2x squared minus 3x minus 5. We actually need to solve that to figure out what these values of x are that we're looking for. So either we're going to factorise it or we're going to use the quadratic equation. So let's see if we can actually factorise this. So having a look at this then, we know if we factorise it, we're going to have a 2x in one of the brackets. So obviously make sure we have a 2x squared. So we've got factorising a slightly harder quadratic here, and our factors can either be 1 or and 5. So let's think about how we could rearrange these. Now one of them is going to double as we've got the 2x, and we are trying to make negative 3 in the middle. So we could have 10 and 1, or we could have 2 and 5, obviously one of those doubling. So if we double the 1, that leaves us with 2 and 5, and we can make 3 out of 2 and 5. So if we double the 1, we want the 1 to be on the other bracket, and the 5 to be over here. And that will allow us to have 2 and 5 and get the 3. Now we want it to be minus 3, so we want positive 2, so we'll have the plus 1, and negative 5, and that would be 2 take away 5, and that would leave us with negative 3. There we go, so it does factorise. Obviously if it didn't factorise there, we'd have to use the quadratic formula, but as it turns out, it did actually factorise, so that's good for us there. So obviously, looking at our first solution in that first bracket, we have x is equal to positive 5, divided by 2 or 2.5, and over here we've got x is equal to negative 1. There we go. Okay, so looking at that, we do actually have two solutions, and I have just noticed that this word here should say values. Okay, so I've just noticed that that should actually say values. There we go, and it just says value. There is actually two values to this question here, so actually that should have said values there, so a little mistake in the words. Okay, so our solution for our first one is 5 over 2, and our second solution there is x equals negative 1. So obviously quite a lot of maths going on in those questions there. We had forming and solving a quadratic. We're all wrapped up within our functions question. So another quite tricky one, but that's the end of that question there, and there's our two solutions for that question, and let's have a look at our next one. Okay, so this question says the functions f and g are such that f of x is 5x plus 3 and g of x is ax plus b, where a and b are constants. It says g3 equals 20, and the inverse function of f when you sub in 33 is equal to g when 1 is subbed in. Find the values of a and the values of b. Let's have a look. We've got quite a lot going on here, but let's have a look with this first piece of information what we can actually find from that. So substituting 3 into function g, let's have a look what that gives us. Well, 3 in place of x up here, rather than writing a3, obviously I'm going to write 3a. So we get 3a plus b, and it says that that is equal to 20. There we go, and we've got a little equation there, obviously with a's and b's in. Now we have two unknowns in our equation here, so there is a little hint that we may have to use some simultaneous equations as we get further along, as we are finding two unknowns here, and that is our usual process there when we are finding two unknowns. So let's have a look at our next piece of information. So the next thing that we're given is that the inverse function of f with 33 subbed in is equal to g when we sub 1 in. So let's have a look. Well, when we sub 1 into g, and as we've just done that with our other function there, subbing 3 in, let's sub 1 into here and see what we get. So if we sub 1 in, we get 1a plus b for that one there. So that's going to be 1a plus b. Let's have a look. Or just a plus b. There we go, so a plus b. So when we put 1 into g, that gives us a plus b. Now we just need to figure out what the inverse function of f is and sub 33 in. So f at the moment is 5x plus 3. So again, let's swap the f of x for y equals. So y equals 5x plus 3. We'll rearrange it to make x the subject. So take away 3 from both sides. We get y minus 3 equals 5x. And then divide both sides by 5. We get y minus 3 all over 5 equals x. Swap round the x and y, we get our inverse function of f is equal to x minus 3 all over 5. Now it tells us it wants us to sub 33 in, so if we put 33 in, let's see what we get. So 33 in place of the x here, and we get 33 minus 3 all divided by 5, which is 30 divided by 5, which is equal to 6. And there we go. So obviously we know that we've got 6 is equal to a plus b up here. So we have another equation. We've got a plus b equals 6. There we go, so we've got our two simultaneous equations. So we've got simultaneous equations here. The coefficients of b are already the same, so we don't have to change either of them. We've got the same signs there, so we're going to subtract them. And then again, now we're looking at some simultaneous equations. So let's subtract these away from each other, and we get 2a equals, because the b's cancel out, 20 take away 6 is 14. So 2a is equal to 14, divide by 2, and we get a is equal to 7. And there we go, and there's our first part of this solution. So let's highlight that. And then we just need to figure out what b is. Well, let's just sub it into one of these two equations. I'm going to sub it into the bottom one here. So we get 7 plus b equals 6. Let's have a look. So 7 plus b, where should we write this down? Let's write it here. 7 plus b equals 6. Take away 7 from both sides, and we get b equals negative 1. There we go, so our other part of the solution there, we've got b equals negative 1, and that's our value of b there. There we go, so we've got our values of a and b, and it was just about breaking down the information step by step and figuring out what we could actually get from those bits of information. And what we found is we actually got two equations there that we were able to solve simultaneously. So, okay, so using a bit of simultaneous equations in this question. And there we go, that's the end of that question. Let's have a look at our last question to finish this off. Okay, so this question says the functions of f and g are such that f of x is 3x minus 1 and g of x is x squared plus 4. Given that f g x is equal to 2 lots of g of x, show that 15x squared minus 12x minus 1 is equal to 0. So let's have a look. Let's find our expression for f g x to start with. So that's putting g into f. So we'll put a bracket around g, and we'll put that in place of in the f function. So we have 3 lots of, and let's just write this down. We're looking at f g x at the moment. And that's going to equal 3 lots of the x squared plus 4, and then take away 1. So if we simplify all of that, let's see what we get. We get 3x squared. 3 times 4 is 12, but take away the 1 leaves us with 11, so plus 11 there. There we go, so that is our first function, fgx. Now let's have a look at gfx. So if we figure out gfx now to start with, not 2gfx, but just gfx. There we go, so we're going to put f into g. So let's get rid of that bracket there, put a bracket around f, and we'll put that into g and see what we get. So that gives us 3x minus 1, x is being squared, so squared, and then plus 4. And that gives us a double bracket there. So we've got 3x minus 1 has a double bracket that we need to expand. Let's just write this at the top here. So we've got 3x minus 1, and another 3x minus 1. And if we expand that, let's see what we get. We get 3x times 3x, which is 9x squared. We are going to do a minus 3x and another minus 3x. That gives us minus 6x. And then negative 1 times negative 1 gives us positive 1, but we're also going to add this 4. So that's plus 5. Again, I've skipped quite a few steps there. You should probably be making sure that you're writing that down. But there we go, that is gfx. Now we obviously want 2 gfx. So 2 lots of gfx. We just need to double everything there. So let's just write that out. We've got 2 lots of 9x squared minus 6x plus 5. And if we expand that all out, 2 lots of 9x squared is 18x squared. 2 lots of negative 6x is negative 12x, and 2 lots of 5 is 10. And there we go, that is our function there for 2g of x. 2g of x, that's exactly what we're looking for, yep. Right, so now it says, given that fgx is equal to 2g of x, and that gives us our little hint there that we can put our little equal to sign in between these. So we've got our two functions, we've got, and let's highlight them, 3x squared plus 11, and we've also got 18x squared minus 12x plus 10, and we need to set them equal to each other. So if we get rid of everything else, and we'll go about setting these equal to each other, let's get rid of all of that. There we go, and we'll just set these equal to each other. So let's get rid of this, put that there, and there we go, and that's what we're looking at now. So here's our little function that we've got. We've set them equal to each other. We actually just need to go about making this equal to 0 now because it wants it equal to 0 just here. So we'll just get rid of some of these pieces. So we've got the 3x squared on the left there. If we get rid of the 3x squared, there we go, so minus 3x squared. And we have 11 equals, and we have 15x squared minus 12x plus 10. And now we can get rid of that 11, so we'll take away 11 from both sides. And we have 0 equals 15x squared minus 12x. 10 take away 11 is minus 1. And there we go, it's all equal to 0. And obviously, because it's equal to 0, we can just put the equal to 0 on the right hand side instead. Now we can just get rid of this 0 equals, there we go, it means the same thing. And there we go, that is our final little bit of that proof there, showing that it all equals exactly what it says up in the question. And obviously do just check that it matches up here, and actually this does match, so we're all good. We've finished on that function question. But there we go, that is the end of our 6 questions. Obviously varying degrees of difficulty, there are no particular order, lots of different types of questions there. We've had some simultaneous equations involved, forming and solving quadratics, you know, showing it equals a particular thing. We had some inverse functions, there was absolutely loads going on there. But that's just a selection of what I would say is some pretty difficult questions when it comes to functions. But that's the end of the video. Hopefully it feels helpful. If it was useful, please like, please comment, please subscribe, and I'll see you for the next one.